Okay, then, so in here, we're just basically talking about how do we work this? We'll forget about this for a while. I'll put that back line. What's the antiderivative of secant tangent? Well, if you remember, the derivative of secant is just secant tangent. We already have this. Integration, think of antiderivative. Well, the derivative is this. If we're here, well, the antiderivative is just secant delta. Okay, then, so secant delta. But what happened to that pi over 2 over pi over 4? Well, that means I just has to evaluate it. Not that hard. Well, what that just basically means, I'm just going to plug in my secant pi over 3, and then I'm going to subtract secant pi over 4. Whatever that is. And for the most part, I think the hardest part is just, what is the antiderivative of secant tangent? Well, hey look, that's just secant. That's the hardest part. The rest, I'm not going to do it because that's just a calculator, and I don't have a calculator with me, unfortunately. That's pretty much it. So let's just look at another example. Okay, so now we have this. Wow, this looks really hard. Forget about this. Sine plus sine tangent delta. What can I do there? Well, I could kind of pull out the sine. When I pull out the sine, this would just be 1 plus tangent delta square. And to kind of check I did my work right, I'm just going to distribute it. Sine times 1, that's just sine delta, plus sine delta times tangent delta. Hey, look, we did our work right. One plus tangent delta over secant square. You know what? That looks really familiar. I want tangent square. So I'm just going to divide everything by cosine square, cosine square, cosine square. When I do that, this just becomes tangent delta square plus 1 plus secant square. Hey, look, instead of writing tangent x squared plus 1, I could write secant square. Hey, look. I could just kind of cancel it. Oh, and don't forget about my limits. I should have been writing pi over 3 over 0. But whatever. And technically delta. What's the antiderivative of sine delta? Well, that's just cosine delta. And I just have to evaluate from pi over 3 to 0. So, whatever this is, of course, I'm not going to do it. Like I said, if we were to evaluate this, we get the answer for this. I think the hardest part is just figuring out the antiderivative, or all these little clever tricks of what they want us to do. Like it's kind of like algebra, but heavy algebra. Now let's look at this example. Absolute value. That's actually kind of hard. Well, let's forget about the absolute value for a little while. Well, what's the derivative of sine? Well, that's just negative cosine x. Okay, then. We have from 0 to 3 pi over 2. Let's just graph it. Let's graph sine x. At 0, we're at 0. It looks something like this. 0 pi over 2 pi, 3 pi over 2, and 2 pi. You could check my work. But if we plug in 0, we get 0. If we plug in pi over 2, we get 1. If we plug in pi, we get 0, negative 1, and 0. They want it from 0 to 3 pi over 2. But notice here that it's under the graph, so it's minus. In absolute value, we can't really have minus. So what can we do here? Well, there's some sort of symmetry at pi over 2. At, yeah, pi over 2. See, this one, and no, my graph is not to scale, but they're technically the same area. And technically this is even. So we could just get the area from 0 to pi over 2 sine x. This will give us this area. But look, we could just multiply it by 3. And I hate to say it, but this is just really the only way I could think of. I'm not gonna do this because this should be algebra. This should be easy for you guys. I think the hardest part is just noticing the absolute value. The best way I could think of to explain is the absolute value is you can't have negatives. And we're just gonna kind of use some symmetry. This is the same as this. If I cut this in half, well, they're the same, and these two are the same. So I'm just gonna multiply by 3. And the reason why 3 pi over 2 is different because it's under the graph, and we can't have negatives there. So we just can't. I just couldn't forget about the absolute value and just evaluate it normally. If I were to do this, well, we'll get from 0 pi over 2, but from 3 pi over 2, it's negative. So it will kind of get rid of this. So if we were to do this, it will only give us this answer from 0 pi over 2. This one's a tricky one. I don't think your teacher might put this in exam. Maybe for some extra credit. I know I had this sort of problem for extra credit. But that's pretty much it. I mean, when you have absolute values, that's when it gets tricky. You have to look at it when it's positive and negative. You know what, this is really confusing and it takes time, but I'm not really going to go too much into depth over absolute values because even teachers don't even like to put in exams. They're really hard, and this was easy, but some just get really hard. So yeah, so if you have any questions or any concerns, leave a message or leave a comment below. So yeah.